All right, Mr. Webb here today, bringing you guys the empirical rule for normal distributions. And our essential question today is going to be how can we apply the empirical rule to problem solve in the normal distribution? And our matching common core state standard is how can we use the mean and standard deviation of a data set to fit it to a normal distribution and estimate population percentages. So let's dive right in. We've already learned about normal distributions and how the mean and the standard deviation define the center and spread, but the empirical rule is going to take that further, and it's going to say that in a normally distributed data set, that approximately 68% of the data is going to lie from one standard deviation above to one standard deviation below. 95% is going to run from two standard deviations above to two standard deviations below. And 99.7, or almost all, is going to be within three standard deviations. So using some of our brain power and using the fact that the normal curve is symmetric, we can actually fill in the percentages for each one of these little sections in between those standard deviations. So do me a favor, guys, and what I'd like you to do is pause the video, draw this drawing, and see if you can't use that 68, 95, 99, 7 rule in order to fill those in. Okay, welcome back, and let's see how we did. So we know that within one standard deviation is 68%, so split in half is going to mean that each one of those two is 34. We know that two standard deviations away is going to be 95, but we know that we've already used the middle 68, so we're going to take 95 minus 68, and it's going to give us 27 split between this section, and the split in half evenly is going to give us 13.5. Using a similar set of logic, we got 99.7 out here, which is going to leave us 4.7 in each of these together, and then that's going to make 2.35. And then finally, this little piece, these two tails on the outside, is going to be 0.3% of our data to get our complete 100%, and then that's going to leave us with 0.15 on each side. So add this to your toolkit, and this is going to become crucial for us in solvings of real-world problems, such as this one right here. So the SAT is a normally distributed test with a mean of 1,000 and a standard deviation. Typically, it runs around 200. Last year's was 194, but we'll go with 200 to make for simplicity's sake. So we've got three questions here. We've got Hackettstown College will only consider students who score a 1,400 or above. What percentage of students score this high? Webshire University says that they will deny students who score below an 800. What percentage of students who will not be able to attend Webshire University? And Hendyville Tech is looking for students specifically in the range of 800 to 400. What percentage of students fall in this range? So first and foremost, what we're going to do is we're actually going to draw all three of these situations to match the situation and match the context. So you can see here, every one of these three pictures has our mean of 1,000 and our standard deviation. We've got three standard deviations above and three standard deviations below. Now for Hackettstown College, you can see we marked at 1,400 and we colored in above. In Webshire, we're at 800, we're coloring below, and Hendyville, we're going to color in from 800 to 1,400. So let's revisit that toolkit chart that we just did with our 68, 95, 99, 7 rule, and let's apply that to each one of these three situations to calculate those percentages. So for Hackettstown College, we're over here at 1,400, which would match on our graph to two standard deviations above. So if we're going to capture in both of these in here, we're going to have 2.35 plus 0.15, or in other words, it's going to give us 2.5% of students could be considered for Hackettstown College. So clearly it's some sort of exclusive, very important institution that few students would be considered there. Webshire University, we've got 800 and below are going to get denied, so that matches on our graph to the -1 standard deviation. So we're going to count up this 0.15, the 2.35, and the 13.5 to get 16. So 16% of students will not be able to attend Webshire University. And finally, Hendyville, we're kind of covering some of this similar logic. We've got this 68 in the middle, then plus a 13.5 is going to give us 81.5% of students are in the desired range of Hendyville Tech. So that's an example of how we do this kind of problem. Now it's kind of your guys' opportunity to put this into action and put this into a real world problem. Is for this assignment, what you guys are going to be doing is you are working amongst a team of top chefs and scientists who are trying to determine if the ideal amount of time to microwave popcorn for Orville Redenbacher. The board expects you to find the perfect time and to justify your reasoning with mathematics, specifically from the empirical distribution. And remember, we must be careful because the longer that the popcorn is in the microwave, the higher the chances that the popcorn will burn. We know that the popcorn pop times are normally distributed, and the average popcorn kernel pops after 84 seconds in the microwave, with a standard deviation of 12 seconds. So here's your task: is you guys are going to answer the following post on Schoology. How long is the perfect amount of time for popcorn to be in the microwave? Present your answer, your argument, and justify your answer with statistical reasoning. When you are finished, reply to 2 other students' arguments. Compare your reasoning. If your times were different, do you still feel like your time is best, or did they change your mind? So that's pretty much everything that we've got for the empirical distribution. I wish you guys good luck on constructing your argument. And just to revisit what we did really fast, we figured out how we can use the empirical rule for a normal distribution. We applied the normal curve for any situation. We used the nature of the normal curve to find percentages within the 68, 95, 99, 7 rule. We applied that to real world problems, and now we're learning how to construct statistical arguments using the rule. So hopefully that helped. If you have any questions, please feel free to add it to our discussion board. And I wish you guys good luck on your assignment. Thank you and have a good day.